Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and I have with me today Mr. Patrick Canning, who is, of course, the president over at Fab-Line Machinery. Welcome, Patrick. Welcome, Patrick.
Thank you. I'm glad to be here.
Thank you so much for taking time out of your busy schedule to be here today. We really appreciate it. So right off the bat, what is your big takeaway for the next 5 years? What are we going to see?
Well, I mean, I think from the standpoint of companies, whether they're big and large, one of the impacts that I see occurring really has to do with advertising and how you get leads, how you get closer to your customers. With the Corona and the COVID situation that we have, a lot of people don't want to travel. So I think social media content in your advertising is going to be very, very critical. And I think that's going to catapult a lot of people to a different level in not only their communication with their customer base, but also in acquiring leads for sales. And then I think even moving into that same venue, I think you're going to see a lot of virtual exhibits at shows. You're going to have a lot of virtual demos. So it makes it more convenient to the end user and customers, so they don't have to hop on a plane and spend 2 or 3 days away from their facilities. That's what I think is going to be huge in the years to come.
Yeah, and I think you're right, and I think there's a lot of trends pointing in that direction, and it's going to be interesting. It's going to be a change for a lot of people that are kind of stuck in the old print world. I think there's always a place for that, but it's going to be smaller and smaller.
Yeah, even the magazines are getting, a little thinner.
Mm-hmm.
Everybody's, in the email world that you get invites for whether it be Zoom meetings or what have you, and it just gives you the ability to accomplish more without getting on a plane and traveling.
Yeah, great point. So give us a little bit of your background. I know quite a bit of it because, full disclosure, Patrick and I used to work together at Niagara and then Clearing Niagara Bliss. So
yeah.
Tell us a little bit about what got you into manufacturing.
Well, my father-in-law, Bob Hurd, in 1987, after Black Tuesday, ended up buying a company called Pacific Press and Shear. And I was not in the industry at that time, and he asked me to get involved. And since then, everything has been, going from not only Pacific to some other companies like you had just mentioned, that it just gets in your blood, and I really enjoy seeing how things are made, trying to find solutions for end users to get them to the point where their company can grow and hire more people. And it's been really a good roller coaster ride for me.
I really like what you said there, finding solutions, because I think that's what people that get into manufacturing enjoy the most, is finding a solution to a problem. And there's a lot of them to be had, especially today with workforce development. What are some of the trends you see pointing towards finding solutions? What are some of the solutions you see in fabrication and in manufacturing?
Well, on the bending side, of course, we sell a lot of press brakes. And over the years, I think a lot of users are taking a look at tools that are very small pieces, that are segmented tools, not the longer tools that are made on planers anymore. They're looking at more precision ground tooling. And that's been coming along over the last probably 7-8 years, but I think it's really exploding more recently. So people can go ahead and exit the tools from the front of the machine in small pieces instead of sliding it out the end. And it just gives them the ability that's more safer for the operator. He can do it more quickly. And that's been a big deal for us over the last 2 years that I've seen changes on. And the other thing that I see people doing is really from a safety standpoint, there's a lot of safety devices that are out there that are used to protect your hands and everything else. And there's some main players out there, and I see that as almost 100% of everything now is much more safeguarded than it was 10 years ago. And more people are getting rid of the older machines, the mechanical press brakes, things like that, and getting more safety conscious. And probably the last thing has to do with the thing that everybody's facing. We talked about this as well, as that is really has to do with the labor. Trying to find individuals that are experts or that are coming out of some schools that can come in and start running their turret punch presses or lasers or press brakes. And that's a challenge. So I see the software companies that are being used to go ahead and be implemented on, say, a press brake, that there's been some really big changes on that, where you're able now to, import like a step file or an IGS file directly into a software, and it will unfold it, put bend lines in it, and select tools to make the product from your tool library, and then give you a bend simulation. And a lot of that stuff was all done manually before, and then it can be sent down to the actual machine, where the operator only has to pull it up and then put tools in the machine. So that makes the operator not have to be as much of an expert on how to truly bend the actual piece and how to make different adjustments. And is he worried about the tooling being the right tooling? It's all done offline. So I think that's been a major adder to the press brake world anyway.
Do you find that more people are getting into that now is it more because it makes the parts better, or do you think it's more because of workforce shortages?
I think it's because of workforce shortages that they're being pushed into it, but then they see a lot of other benefits, because the software is able to link not just press brakes, but they could link a press brake, a laser, a turret, a water jet, all off of one software. And it's made to be a little bit easier than it was 6-7 years ago, and it's more integrated into maybe sometimes their current softwares that they might have, so they don't have to buy another third-party software. So it's very intuitive, and I think user-friendly for the customers. It's easier to learn.
Yeah, I can see that's certainly a trend that's people are getting into the software, and they're getting into more high-tech things. What other ancillary devices are people getting into that can help them improve their productivity?
I think in our world with bending is that a lot of customers that might have pieces that are usually, it comes into play when it's at least a 1/4-inch piece of plate that's at least 10 foot long, and then of course it could be 15 foot, 16 foot, 20 foot, whatever. But once it gets to the area of 1/4 by 10, it's difficult for an operator to not only push that material into the bending area, but also when that lifts up, when it's actually bent and it starts to come down, usually it requires more than one operator. So I've seen actually retrofit items where you have sheet followers, where now you have less workman's comp injuries, because roughly what happens are these arms follow the sheet as it moves upwards, and then when it comes down, it slowly comes down, and the actual sheet actually pushes those sheet following arms down to the zero position. I've also seen where customers are taking ball transfers and actually implementing those into the support arm. So now it reduces drag. So when you push the actual material into the bending area, it's pretty easy to do. They're not really struggling with that type of a process. There was another customer I saw. In fact, we sell this as well, but it's when you do certain applications, the customer usually has a scribe line. So in a scribe line application, you might have something that's maybe a 6-position or 8-sided pole, 12-sided poles, or you might have something that's a cone. Okay, that usually requires 2 operators, and the one operator is yelling to the other operator to see if you're aligned properly to go ahead and go through with the bend. Very time consuming. So now, from really the saw industry is where this came from, is you can get a high intensity, it's almost like a pointer on the one end, and it shoots a line all the way down the metal. So now both operators can align it very quickly. And there's less scrap. Everything is really a much more important for the customer, and less not only scrap but even injuries. So I see that more and more as I get out there, and that's only been over the last probably 4 or 5 years, but I see that taking a big jump as far as people using it.
Do you find that people need more feedback now as far as confirmation of the parts? Like, for example, are people that are customers of fabrication equipment, are they asking for more confirmation that not only was this part made in a quality manner, but they want it checked out using some type of a confirmation system that the controls can actually produce that kind of feedback?
I see where customers have a little bit more automation. So they're taking the part from the bending side and going to, say, a welding apparatus, and they're not having anybody touch it. And if the bend is not accurate enough, the weld is not going to be as good. Then you're going to have a secondary process of maybe cleaning up that weld. And that comes into play with not only angular accuracy, but also the crowning system that's on the machine itself. And I see customers very concerned about that. They're usually checking after, the first part's not always sometimes going to be perfect. Okay. So they'll make the first perfect part, do all their savings, and then put that, down into the computer. They'll start bending and finish it. But when they switch different types of lots, where it might come off of a different coil and it affects thicknesses and things like that, there are people looking at different angle measurement systems and things, but it's not easy. But, angle measurement systems have now much more discussion than they ever did 4 or 5 years ago. It's like no discussion at all. But now the discussion is how they can do that. How can they assure that if the material thickness changes, how can they compensate better so that down the path where this part goes becomes a better system? You don't have so many problems in welding and fit up and set up.
Sure. Do you see that this new equipment is increasing how quickly things get obsoleted or get kind of cast aside? I know used to be on the laser side, whenever a new laser came out, you had to decide if you were going to chase that down the road because it, almost every year they're coming out with a new laser. Do you find that that's more of a more frequent thing now compared to, I mean, it used to be on a press brake. You would probably sit on a press brake for at least 20 plus years, maybe more. Now it seems like changeovers more. What's your vision on that?
Well, I think for sure from a press brake standpoint and a laser standpoint, both, when something new comes out, you're going to see a lot of people buy the new and get rid of what they've currently got. On the press brake side, of course, the new thing is electric press brakes. That's been here now since about the last 12 years, maybe 13 years, but it's grown quite a bit. And it has some significant advantages for the user. Press brakes that are electric now, most of them go up to about 150 tons with some manufacturers. I mean, you can't get like a 500-ton or a 400-ton or a 300-ton electric brake, but that has actually had a lot of good impact with the users in that it's extremely quiet. There's no leaks because you're not using hydraulic fluid, no hydraulics at all. It's usually run by either a ball screw or some type of a belt apparatus. And that has been very well received from the customer base. And that particular market is growing more than 10% a year from the standpoint of those being sold. On On the laser side, what I see is that the CO2 technology, of course, has been replaced by fiber, and anybody that's got CO2s is looking at replacing them if they haven't already, mainly because of the speed as well as the maintenance that had to be done on the CO2 side. And then the other thing I see that's come out more recently is that on the laser side, people like to have secondary applications like maybe a tube being cut with a laser. Now they've got combination machines where you have a flat cutting laser and the tube cutting all underneath the same, enclosure. And I think that's going to be a game changer as well, because they're two different applications combined without secondary handling. And I see that as a big play. I think we'll see more of that in the shows to come here this year and the years to come.
What about the difference in, speaking on those lasers, what's the difference in things like consumables and that?
From the standpoint of the fibers, I mean, you've got, the tips of the head have to be a consumable and things like that. But there's no, like the mirrors don't have to be aligned, nothing like that. So on a PM, where on the CO2s, it was a good idea to have a PM at least 2 to 3 times a year. With a fiber, you could have it annually. And really, consumables are mostly based upon the cutting head of the different thicknesses that you do, and making sure that you have the appropriate tips. No other items really are really what I consider a consumable. And most manufacturers, when they sell a laser, they have a consumable kit that they supply you in like a spare parts package that they give you, and those are directly from the manufacturer of a cutting head supplier. So they're easy to find. Most cutting head suppliers are all in the United States. There's only 2 or 3 major ones. And the fiber laser has just changed the world as far as the cutting of material. And they just continue to gain in speed. They continue to gain in cutting power. So, but consumables and even maintenance on them is really, really quite low.
Now, when you got into manufacturing, was there anything that was impactful that you thought, wow, this has changed my life? Obviously, getting into it was one step. Was there anything that either some piece of advice you got from somebody or maybe even a book you read that was impactful that changed the way you thought about manufacturing?
I think I read quite a bit of articles when actually back in the early mid 70s, let's say, when people that were bending had a struggle engaging the material, and that's when Herco and Automec and these guys came out with different back gauges that changed everything in the bending side, because it made it so much faster to do the part and so much more production was achieved. When I read that, I thought, well, what is going to be the next thing that's going to happen? And when hydraulic clamping came out and you saw that, I mean, it was just, it was like, well, why didn't they think about that, years and years ago? Because it really changed a lot of items for the people that are trying to make a part. Not only being able to unclamp quickly, where you had to have some type of a wrench that would go all the way down and unloosen all these bolts, and it would take 30, 40 minutes. Well, now it could be done in like a couple minutes. And that changed so much from the standpoint of the people on the floor, from not only from safety, but also, the time that it would take, and the production times that went up. The next thing I think that's going to happen is going to be really related to what I talked about before. And when I see this, it's amazing. And that's really the software. When you see what happens when somebody in engineering just takes and downloads a file, and in a very short period of time, you've got a program already completed with the tools selected to go down to the floor. It's mind blowing. when you see that occur, because in the past it might have taken a couple hours to do that, and now it can be done in a minute, a couple minutes.
Right.
That's where I think that things are heading now. And the next thing that you see is, you see a lot of robotic press brakes out there right now. I think they still have some more time to grow, but that's out there because they want to try to replace labor force. I think it'll be interesting at the shows if there's any type of new technologies that are coming out for not only laser cutting and bending, but what other people are thinking. There'll be some new equipment, I'm sure, come out, and new ideas here at the show that'll be coming up at Euroblack in Hanover in October. Usually if that comes out, it's not available in the United States for a couple of years, but it's exciting right now as far as the technology, and it changes so quickly. It's amazing.
Wow. I know that when you mentioned hydraulic clamping, I can remember one of the big things that was different in hydraulic clamping was seating the tool, how much time it used to take you to seat the tool. Now you press a button and it automatically seats, because the tool is just a different tool. It's not your standard tool. It actually has where you're actually is precision ground in the area where you're actually clamping. And it was just, you're 100% right. It was just so different. It was just a completely different way of thinking about it and addressing the problem. When you talk about software, do you see more people using 3D modeling for their parts now? Used to be everything was in 2D, and you had to try and convert or make it into a 3D model for when you were actually going to be bending it. Do you see more parts coming in 3D now and being processed into the software?
Yeah, I see that growing. If I take a look at Fab-Line, 3-4 years ago, we might sell one machine a year or two machines a year that actually had a true 3D controller. Everything else was 2D. And now we're selling 12 to 15 a year that have 3D controllers. And it's really based upon the software. It's not based upon that the operator needs to see it in 3D. It's just that if you're going to use, a 3D engineering software, it makes it a lot more simple to go and have a 3D controller to accept it and then visualize it and, download everything into it with 3D offline programming software. And I see that on the majority of the people I see it are a lot of OEM builders, not as much as in job shops. Mm-hmm. Because if they manufacture a product, they usually use other items besides the press brake. Okay, they might use a laser, they might use a turret, and they can link all of those into that software. And since they're building a product, they know what they're going to do every day. They know what parts, that they need to make for assembly and for everything else in the production schedule, and it makes sense for them. On a job shop, it's a little bit more difficult. I've seen it out in the field, but we don't see that coming up near as much as if you had had an OEM. Mm-hmm. So, that makes sense?
No, that absolutely does, and I could see why that would be the case. Do you see more of a demand from manufacturers on the processing side? So beyond just, hey, how many parts did you make? Planning accordingly. For instance, on a lot of the turrets used to be nesting. How do I nest the parts so that I optimize my material usage? But that also doesn't solve your problem of, hey, I need to get this part out. So you had to kind of give it what you wanted as far as the sequence of operation. Is there more tracking of that now?
Once again, I see it in both OEMs as well as job shops on this, but I see a lot more barcoding going on. Mm-hmm. And once it comes off, say a laser in the flat, there'll be a barcode on it, and it allows that operator to go in to take a wand and hit and roughly scan that barcode, and it gives them the ability that will implement the actual program directly into the controller. Okay, and then
Right.
they can go ahead and finish that part being made. And I see that as being used only to track if they have a problem in a coil or a problem with some type of a part that's been engineered, that they know exactly where that part went, what assembly it went into, and so forth. I see that more and more now, as far as mostly bigger shops. But I mean, I see that much more often now.
Right. And I could see that because when you think about the case that always sticks out in my mind is the Bridgestone Firestone thing when they had the problem with the tire failures. And what did everybody have to do? Since they weren't tracking the tires, they had to basically recall a significantly larger portion than were actually bad tires, just because they couldn't prove it wasn't those ones.
Okay. Yep, I agree. Yeah, because there's no way otherwise.
Right. That's right. And you know how it is, especially if you're dealing with automotive. If you can't prove it's not your problem, it's your problem.
Yep.
You got to be able to prove, hey, look, here's mine, here's the quality, here's the check. It wasn't my fault. So, okay, then they'll go chase another rabbit down the hole. But there's no question that you better be able to prove it wasn't your fault. So what are some of the things that you see being a change that we need to look at from an industry standpoint of attracting people to the workforce now?
It's difficult because of sometimes the younger generation kind of want instant gratification. They see this as still a kind of a dirty job, quite frankly, working in a plant. There's a couple schools that we've had that we've actually we've hired some people from, and the intrigue that they've got is really has to do with electrically and software and what the equipment makes. They're very intrigued on, when they come in, they look at a press brake, they're like, well, what do you use this for? And when we bring them in and we train them on service and they go out on a service call and then come back and they'll just be lit up as far as what they're doing to make this. And if they see an assembly or if they see something down in down the bay in the plant that's actually a full product, they seem to like that. And I think that from the standpoint of trying to get that instilled in the schools to somehow, I guess, show, what is the end degree of this, because they go into a school and they see like a press brake or a shear or a plasma, and they teach them how maybe it's used, but they don't really see what it's in the field is used, what they make with it.
Right.
And I think when they think out of the box like that, I see them very excited. Yeah. And I don't see schools doing that. The schools just teach them how to, the turret works and, what some of the codes are to program it, or a press brake. They talk about B-die width and the punch radius, but they don't take them and say, okay, let's see a truck body being built, or let's see something being built. And then when they're driving on the road, they'll say, oh, I know exactly how that's made.
Mm-hmm.
I just don't see that. If we could do that, I think that would be helpful.
Yeah, I agree. I think that's one thing that excites the kids. When I've worked with some of the people at a couple of the colleges locally and some of the different programs that we've been involved with, it's interesting because the kids are definitely interested. When you've got a robot on it, they really get intrigued. They get interested when they see the end result, the parts.
Yep.
So that they can now envision what this does. And I think that's, the more we can do that, the better off we're going to be, I think, to get people interested is how does this impact people, and so that they understand what their contribution is to the world as a whole. Here's how you're being impactful. Well, we're right at the end here, Patrick, so tell everybody how they can reach you.
630-251-1344. That's probably the best one.
Okay.
And then my email is my first letter, P as in Patrick, and then my last name, CANNING, then the @ and then Fab, Frank Appleboy, a dash, the word line.com.
Great. Well, thank you for being here today. We appreciate it so much, and you have a great day, sir.
Thank you. Take care. Bye.